discussing about very critical concepts of a fixed income. These are zero coupon rates or spot rates, and we will also discuss about what is YTM and forward rates. And the relationship between them. You would have heard about the definitions of spot rate and YTM, so I will not go into the definition part of it. What we should understand is the concept behind this spot rate, YTM, etc., so that you will be very clear, and any type of a question that comes around this spot rate or YTM or say forward rate, you will be able to answer them. So let's start with the spot rate. It is also called as zero coupon rate. Why zero coupon rate? So this is zero coupon means if you invest in a bond and you hold it and you have its maturity, hold it till maturity, the bond will not give any coupon in between. Coupon means it is the interest, and only you will get the final value at the maturity. So you invest here, whatever price you will pay, that is called your bond value. So you invest the bond value here, and finally you will get the par value of the bond. So if you have noted our first session, we have discussed about this is called present value, and this is called the future value, that as per the time value of money theory. So obviously the present value will be lesser than the future value. So you invest here less value, less amount, and you get more amount over here. The difference amount is going to be a interest portion. This interest rate is called the zero coupon interest rate. You don't receive any in between coupon, only the difference between the future value and the present value will represent your interest portion. So that if you present it is an annualized form, then it will be called as zero coupon rate, or it is also called as spot rate. In the market, it's very rare you will get such kind of zero coupon rates or zero coupon bonds, because you invest certain money today and you expect that you don't pay me in between, you will only pay at the time of maturity. So what that the risk is very high, because you do not know that bond seller is going to default or not. So the risk is very high. As the maturity goes up, the risk becomes more. That's why normally we have the coupon paying bonds. But before going to the coupon paying bonds, we will just clear up the concept about the presentation. We have discussed about PV is equal to future value into 1 upon e to the power Rn. This is in the continuous compounding basis. And this portion we have discussed about is the discount factor. Yeah. Right? So, if I will tell that if my interest rate goes up, what happens? If your R is the interest rate, if R goes up, then your e to the power Rn goes up, and therefore 1 e to the power Rn goes down, and therefore your present value, which is also known as the bond value in our case, is going down. So bond value goes down. That's why we tell that bond value goes down. When interest rate goes up, bond value goes down. Now it will be the reverse. If the interest rate goes down, then bond value will go up. Now what will happen if n will change? Let's say what is happening in case of n, I will replace n. N is the duration of the maturity period. So if n goes up, e to the power r n goes up, 1 upon e to the power r n goes down, and therefore the bond value will go down. Now if n goes down, e to the power r n goes down, 1 upon e to the power r n goes up, so bond value will go up. If you put it into a perspective, is that longer the duration, more is the risk, and therefore you will willing to pay a lesser price rather than you will not be interested to pay a higher price if the risk is more, right? So if you have the risk high, then obviously you will be interested in getting more return and you will be interested in paying only lesser value. That's why the bond value is lower if the duration increases. Duration increases, risk increases, and therefore bond value goes down. Duration decreases, risk decreases, and therefore bond value will go up. And from here, as we said that if zero coupon bonds are high risk, then the very commonly used as the coupon paying bonds. So we understood what is spot rate. I am now bringing into another concept for YTM, and then we will try to link between these two. Before that, we should understand what is YTM. Now we understood what is a zero coupon bond. Now I am taking you to a coupon paying bond, very frequently used type of a bond. So I am taking, so everything will be yearly, so 6 months, 1 year, 1.5 year, let's say only a 2-year bond, and receiving coupons C, and here I will be receiving P plus C, right? Now here you take the money at 0.5 year, you get certain coupon amount in the 6 months. That what is the present value of this coupon which I am going to receive 6 months? What is going to be the present value which is for the 1 year coupon payment? What is the present value of 1.5 years, right? Because what we have told is this is the bond value, right? So we are paying here. So this is the total present value of, let's say I am saying this is future value 1, future value 2, future value 3, future value 4. And I will say that this is PV1. So if I will take discount it, I will say PV1. If I will discount this, I will say PV2. If I will discount this, I will say PV3. And if I will say discount 4, then I will say PV4, right? So sum of all the PVs are going to my bond value. Just to take that example of the zero coupon bond where I was paying here and I was not getting any interest till the maturity, right? So we invested here bond value, but we are not getting anything. Now here at least you are getting the coupon payment. So where is the risk is higher? Obviously the risk is higher here because you are not getting any. Now in this case, if the bond seller is defaulting on its payment, so the entire amount becomes defaulted. Now in case here, in case he defaults somewhere here or here, at least you have got some amount of cash. So only the remaining portion is your default risk. That is why it says that the risk is less over here. Therefore, when you have lesser risk, the effective interest on this will be lesser, right? Obviously, because of less risk. Now here it is the higher risk, so higher will be the interest rate. So if I will take a relationship between the yield on this and the yield on this, obviously the yield will be increased, right? Now what is the yield on this? Normally we express, there is no uniform yield. First of all, we have to appreciate that there is no uniform yield, because this coupon what you are receiving is only after 6 months you are receiving. This coupon you are receiving 1 year. So my interest rate for 6 months is not the same as the interest rate for 1 year, is not the same as the interest of any other maturity, and therefore what I have to do is I discount it to them and then find out all the PVs, which will, and then take the summation of that. See, so in this case let me replace. It's very easy. Now what is the PV? The formula will be, the PV1 will be C into 1 upon e to the power. So this rate is, let's say, R1 and N1. Okay. So similarly, this will be PV2 will be equal to C into 1 upon e to the power R2 and N2. So similarly, C1 upon e to the power R3 N3. Similarly, this is PV4. This time it will not be C alone. It will be C plus the principal, the face value, into 1 upon e to the power R4 N4. This is e to the power. So ultimately, if you now summarize these, what happens? The formula, the one value. Now if I summarize this, it becomes PV is equal to C, I will take out common, and it will be all 1 upon e to the power R1 N1 plus 1 upon e to the power R2 N2 plus 1 upon e to the power R3 N3 plus 1 upon e to the power R4 N4 plus P into 1 upon e to the power R4 N4. Now everything is different. So what I am doing is, let me give a common interest rate. So theoretical interest rate will give, let's say there is only one rate, and so what will happen is that C into 1 upon e to the power R is the common I am saying, and N1, it will remain like that, plus similarly plus 1 upon e to the power R N4 plus P 1 upon e to the power R N4. So a hypothetical interest rate I have taken, uniform interest rate, and I have taken N. Now what will happen? You know N1. This is this R1 interest rate. You see that there is no coupon payment is happening. So it can be represented as R1 is a zero coupon rate. Zero coupon rate for 6 months, or spot rate for 6 months. Okay. And this R2, which is the interest rate for this period, so that is spot rate for 1 year. So you know this R1, you know this N1 is the tenure, you know the coupon, you know the face value, and R4, everything is known. So now we can easily find out, because here everything is known except R is unknown, and R is the only single parameter which is unknown, and therefore one equation is there, and from that one equation you can easily find out what is R. Now once you solve the equation, then you will find the value of R. Let me not keep the same, I am changing it to capital R, because not to differentiate between the spot rate and this rate, this theoretical rate. So once you solve this equation, you will find R, and this R is known as YTM, or yield till maturity. Here you might have seen or read the definition of YTM is if you invest on a coupon paying bond till its maturity, the interest rate that you are going to realize is nothing but its YTM, right? So, but this interest rate we are discussing. So this is the interest rate that we are going to get in the bond on a coupon paying bond. And what on a non-coupon paying bond, we got the zero coupon rate or the spot rate. What we discussed, the risk is less over here and therefore the interest should be less. The risk is very high on the zero coupon bond, therefore the interest rate should be higher. Therefore, if I'll tell for the same tenure is that what is the relationship between zero coupon rate and the YTM rate, then you can very well say or the spot rate, both are same. So you can very well say the spot rate will be higher than the YTM at any point in time. So always the spot rate will be higher than the YTM rate. Okay, because the high risk, this is risk is high, so interest rate will be high. This is risk is less, so YTM rate will be less. For same tenure we are discussing. Yeah. Now we will discuss about the forward rates. This is 1 year and 2 years, let's say. So I have one interest rate on for 1 year and 2 years. Let's say that the interest rates are something like this: 5% for the first year and 10% for the 2 year. Yeah. I'll take same PV, future value 1, future value 2. We will see how the forward rates are getting related, and we can find out how can we correlate between the spot rate and the forward rate. What kind of relationship is this? So I have taken spot rate for 1 year is 5% and spot rate for 2 years is 10% for to easy understand. Now my FP1 will be your PV into 1 plus 0.05 and FP2 will be PV into 1.10 square. So this is as per the time value of money theory. So what happens? This is the 1 year rate. My forward rate is this one. If I'll say forward rate F12, forward rate from 1 year to 2 years is FP2 divided by FP1 minus 1, and that is here. FP2 is 1.10 square divided by 1.05 minus 1, which is approximately, you can calculate, it will come around 15%. The interest rate, the forward rate will come around 15%. So that means if, and this is, look at this, the first year interest rate is lower, the 2 year interest rate is higher. That means it is an upward slope, or it's a normal yield curve. If you plot an yield curve where yield versus time, then you will find like this. So if such an upward sloping curve, then what is happening? The forward rate is much higher. It is beyond, you can say, 5 and 10%. In case of an upward sloping curve, the forward rate will increase sharply. As we have seen here, the forward rate is way above the spot rates, that is 5% or 10%. So this will be our forward rate curve and this will be our spot rate curve. Now, this is the scenario if the spot rate is an upward sloping curve or the normal yield curve. Now we will study about what will happen if the spot rate curve is a flat curve or if it is a downward sloping curve. Very simply, I will give you a table which will help you to figure out the nature of the forward rate curve in different scenarios. Yeah, this is spot rate. So this is upward sloping. This is flat and this is downward sloping. So we will see what is happening to forward. So it increases sharply or it increases faster than the spot rate. Here in case of a flat, forward rate tries to catch us up with spot rate curve, and in case of a downward sloping curve, then the forward rate will decrease faster rate. So if you remember this table, it will be much easier to find out the relationship or to answer all kinds of questions around the relationship between the forward rate and the spot rate curve. This is the spot rate curve. So you will see that the spot rate curve is till here. It is going and then till here you will see that it is upward sloping, and then it is trying to kind of flatten. So here it is flatten and here it is downward sloping. So now if we plot the graph of forward rate, so as per this table increases faster during the upward journey. So forward rate, let's say, starts from there and it will go very fast and it will try to reach very peak, and then when it flattens it will try to catch up. And then it will decrease at a much faster rate. So this is the graph for spot rate graph, and this will be the graph for forward rate. Hopefully you have liked this session. Do attempt to all the questions that are given in this particular video. During the entire session you will find 5 different questions that will be asked to you. Complete them and write your answers in the comment box in the YouTube video. And if you have liked it, click on the like button over here and subscribe to our YouTube channel so that we will be encouraged to put on more such videos that will be helpful for you. Thank you.